Alright, for our second video, we're going to start off by looking at good sampling methods. Now, probability sampling, or also called random sampling, is definitely the best way to do it. Why are these sorts of sampling methods considered good? As long as the individuals are randomly selected, then no group should ever be overrepresented or underrepresented. As long as you're sampling things randomly, it gets rid of any sort of bias. So as long as your question is worded well and your group is no longer just kind of specific to certain individuals, as long as everybody has an equal chance, it makes for a good sample or a good data or a good survey. Random samples rely on the absolute objectivity of random numbers. So as long as everything is chosen completely randomly and everybody has an equal chance, that makes for a very good survey. Simple random samples, again, it's still part of it's considered random. Why are they good? The simple random sample, the SRS, is made up of randomly selected individuals. Each individual in the population has the same probability of being in the sample. So nobody has more chance than anybody else to be part of it. Everybody is completely equal. All possible samples of size n have the same chance of being drawn. So again, this is very different from that systematic random sample because let's say two people's names are right next to each other alphabetically and we were choosing them alphabetically every fifth person. Those two people would never have a chance of being together. So that would make the samples not have the same chance of being drawn. So how do you choose an SRS of size n from a population of size capital N? Label. Each member of the population gets a numerical label. Then, in some form of random draw, so draw a number from a hat, roll a dice, use technology such as a calculator to generate random numbers, you somehow get random numbers to find out who's going to be picked then. So again, if we were to take everybody alphabetically and just the first person we call them 1, the second person 2, all the way down through the last person is 5,000 or something like that, and we somehow drew random numbers, that would be a good way to find a random sample. So, for an example, if we wanted to select a random sample of 5 people from a class of 20, step 1, we would list a number, all members of the population, which is the class of 20. We would assign each person one number. So first person's number 1, second person's number 2, all the way down to person number 19, person number 20. Then we could use technology to generate 5 random numbers between 1 and 20. Now this form is going to be used to, if you had a TI-84 or 83, this is the way you would go about generate your random numbers. From a graphing calculator, steps to achieve the calculator screen at right. You'd hit the button Math, hit over, 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 click down, 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 4 of them, and hit Enter. This should produce this form where it says random integer, R-A-N-D-I-N-T, and then in parentheses you would click in 1, comma, 20, comma, 5, and then close your parentheses. Now, after you've hit this, you'd hit Enter, and it will generate your 5 random numbers. So you'd repeat this until you have your 5 different numbers, and you don't want repeats allowed there. So you can't have number 3 and number 3 given twice, because you don't want to draw person number 3 twice. That doesn't count. Now let's say you have the Casio FX9750G2 that some people have. From your main screen, this would be the buttons you choose. These are going to be the buttons you're going to go from. Hit Option, O-P-T-N. That's at the top next to your yellow Shift button. You hit F6. On your screen, it'll look like kind of a blank triangle. This just means you're clicking over, scrolling through your options there. So you would hit, again, Option, then scroll over. You'll see a button that says P-R-O-B. That's right above your F3 key. Hit F3. Okay. F4, you will see on screen, it'll say R-A-N-D. That means you're generating random numbers. And we want to use F2. That one is I-N-T. Those are integers. So this will not give us any decimal answers. This will just be integers in between whatever things that we use. After you click integer, this should be on your screen. R-A-N-I-N-T number, saying random integer number. Now you're going to click in 1, comma, 20, comma, 5, close your parentheses. Okay, when you do that, I'm just going to type it in here. This is what it should look like. 1, comma, 2, 0, comma, 5, and close the parentheses. You should see this on your calculator screen at this time. Okay, once you've got that in there, when you hit enter, or the EXE, that is going to give you a list. Yours might look something like this. It'll say answer at the top. Here are 5 numbers, 1, 2, 3, 4, 5 random numbers that go from 1 through 20. There are 5 of them. So mine spit out 3, 7, 4, 11, and 9. Notice that these don't necessarily go in order. It should go 3, then 4, then 7, then 9, then 11 if we went in ascending order from smallest to biggest. But because it's completely random, it gives us even a random order of them too. So mine gave out something like this. Yours will probably look a little bit different, but that is how you would generate 5 random numbers 1 through 20. Now if you wanted them to be like 1 through 100, you would just put 100 in here, and there'd still be 5. Let's say you only wanted numbers 20 through 100. You would just put 20 at the beginning, 100 here, still generating 5. Let's say you wanted to generate 10 random numbers. You would change it back here. 10 random numbers going from 20 to 100. So this would be how you kind of change those options. These are the buttons you're going to push in that order to get to this spot to help you generate some random numbers. So make sure you kind of remember that, or you can use that for later on. We're still looking at some good sampling methods. This one is, we're going to be going over the stratified random sampling method. Why is it considered good? It's essentially just a group of the simplified random samples, but that is performed on subgroups of the population. So again, let's say we're looking at a high school. Well, instead of just looking at everybody in the high school, we're going to separate it into groups like freshmen, sophomores, juniors, and seniors, and then within those groups, we're going to do a simple random sample. So as long as it's still put into groups that are simple random samples, it's still going to be a good sampling method. The subgroups are chosen to contain all the individuals with a certain characteristic. So again, things like being a freshman, being a sophomore. Maybe we want all of the high schoolers, but we want to break it up boys and girls. So again, that'll make sure that we can still hit everybody. We just put them into different groups. So how do you create one? Some examples would be like if we take the entire population of a college, we break it into males and females. So again, like I said, boys and girls. When we do that, we would still take a simple random sample of all the males, a simple random sample of all the females, but then we would just combine all of that data into one big piece. We could also divide the population of California into major ethnic groups. So all Caucasians, all African Americans, all Hispanic Americans. Again, when you break them into groups like this and still do a simple random sample of that, it's still considered a good sampling method. We could divide the countries in America, or counties, sorry, counties in America as either urban or rural based on criterion of population density. So that way we would still be able to sample everybody within these counties, but we would have them, this is what happened when we asked all of the urban counties. This is what happened when we sampled all of the rural counties. So then we'd be able to see kind of a difference between the two samples, or between the two answers, but we could put them all together into one big simple random sample as well. Notice the simple random sample taken within each group in a stratified random sample do not need to be the same size. So let's use the college one for example. If we wanted to divide an entire college into males and females. Now let's say I asked 1,000 males a question, and I was going to ask the females that same question. I don't need to ask 1,000 females. I can ask more. I can ask like 1,200 females and see what they say. I could ask less. I could ask 800 females. As long as the number of females that I ask is still a good representation. So I'm not just going to go up and ask like 1 or 2. I still have to ask a pretty high percentage of all the females there. I still need to ask a pretty high percentage of all the males there, but they don't need to be the exact same number. Caution about sampling surveys. Non-response. So people who feel they have something to hide or who don't like their privacy being invaded, they probably won't answer. which means they will not be part of the population. Or, I mean, they are part of the population, they will not be part of the sample. They won't be added into your sample when you're surveying them. They are technically underrepresented in that case. Response biases. So it's a fancy term for lying when you think you should not tell the truth. So like if your family doctor asks, how much do you drink? And some people might not want to answer that completely correctly. Or a survey of female students asking, how many men do you date per week? Again, maybe they don't want to answer that completely correctly. So their response is going to make them seem a little more or less in that direction of, whatever it is you're sampling. Sometimes people also simply forget and often give erroneous answers to questions about the past. So if you were asked how many parks you have ever visited and you had no idea, and so you simply just said, oh, probably like 120. Well, you had no idea, you can't remember, but you did give that data, so now that data is going to be used in the sample. Wording effects. Sometimes questions worded like, do you agree that it is awful to? So agreeing is an affirmative, awful is a negative. So it's kind of hard, these don't necessarily match up. So sometimes it's saying you are prompting to give a particular response to something. So the way that a question is worded can also affect the way people answer it. So you need to make sure that you are very cautious about how things are sampled. Also beware, undercoverage. Undercoverage occurs when parts of the population are left out of the process of choosing the sample. This typically occurs because there is no accurate and complete list of the population. So, for example, because the U.S. Census goes house to house, homeless people are not represented. Illegal immigrants also avoid being counted. So geographical districts with a lot of undercoverage tend to be poor ones. Representatives from richer areas typically strongly oppose statistical adjustment of the census. So when the census is taken and they're trying to find out how many people live in America and how many people live in this area and are at this income level or whatever it is, they don't really get a chance to talk to homeless people or illegal immigrants because those people either cannot be contacted or don't want to be contacted. So that means that the survey is incomplete. It doesn't have good data being used there. So for example, to access the opinions of students at the Ohio State University regarding campus safety, a reporter interviews 15 students he meets walking on the campus late at night who are willing to give their opinions. So what exactly is the sample here? Is it all of those students who are walking on campus late at night? Well, that might in a sense be considered the population, or at least part of the population here, but it's not the sample. So remember, sample is the people that we actually got data from. All the students at the university with safety issues. Again, we didn't ask every single person who had safety issues. The 15 students interviewed, this would in fact be our sample, because these are the only people we have data from. We wouldn't say that it's all students approached by the reporter, because even though he may have approached people and tried to talk to them, that doesn't mean that everybody gave a response. And that doesn't mean that we have data from each and every person then. So it's really only the 15 students that we interviewed. And in Ohio State, there's way more than 15 students. So this sample is going to underrepresent a lot of people. Also, let's take another example. A simple random sample of 1,200 adult Americans is selected and asked, in light of the huge national deficit, should the government at this time spend additional money to establish a national system of health insurance? 39% of those responding answered yes. What can we say about this survey? Well, in a sense, the sampling process is sound, but the wording is biased. The results probably understate the percentage of people who do favor a system of national health insurance. So because it was worded in such a way that says, well, remember that there is a huge national deficit, it makes you already think, oh, this is a bad thing. We don't need to be spending extra money, or we don't need to be doing things that are going to help out this national system of health insurance. Should you trust the results of the first survey? How about the second one? Why? Well, again, in this first one, we were only looking at 15 students who happen to be walking on the campus late at night and are willing to give their opinions. Many times, students who are walking late at night kind of on their own and are willing to give their opinions, these students are not necessarily going to represent the entire population. A lot of students are too afraid to walk around campus late at night because if it does regard safety, they know that it might not be safe to walk around late at night. So a lot of those students won't have much to say or be a good represented sample. So no, we probably shouldn't trust the results of the first survey. Plus, since only 15 people were asked and there's way more than 15 people on that campus, we probably didn't get enough data. How about this second one? Well, this second one, again, it sampled the right amount of people, and it did a good job of making sure that it was randomly selected, but the way that it was worded kind of skewed the data a little bit. So we might not be able to trust it 100%. So, an important note here, you can't trust the results of a sample survey until you've read the exact questions that were asked. The amount of non-response and the date of the survey are also important. So, if you can get the information about a certain data and ask when was it asked or what were the questions exactly asked, do that. That'll help you determine whether or not the data is useful. How can we use data from good sampling methods? Well, how about this one? Here's an example. At the preview of a movie, 6 people walked out of 500 people. So 500 people went to a movie preview or premiere, and 6 of them walked out. It means they didn't really like it, they were mad at it, or for whatever reason they just didn't want to stay there, so they left. If 6 out of 500 walked out, now suppose 600,000 people went to see the movie, we should be able to estimate the number of people who will walk out, as long as this was a good sampling method. So let's assume that it was, and 6 out of 100 or 6 out of 500 walk out. We would create a little ratio here, 6 out of 500. To complete our proportion, we'd set another ratio, x out of 600,000. 6 out of 500 walk out, so x out of 600,000 will walk out. Now, how do we solve for a proportion? We cross multiply and divide. Cross multiplying gives us 500x equals 3,600,000. Divide both sides by 500, and we get x equals 7,200. So, without even having to go and count everyone, we would assume that around 7,200 people will walk out of the movie. Let's look at another sample then. Again, we're going to assume that this was a good sampling method here. In a 125-seat section of a ballpark, 38 people bought programs. So even though we didn't look at the entire ballpark, we just looked at one section, we found 38 people who bought programs. Well, let's say that entire park holds 54,000 people. Estimate the total number of programs sold. If you are the person who is selling these programs, you might want to know something like this, because this will help you determine about how much profit you should be getting. So we'd set it up again, 38 people out of 125 people. This was kind of our sample size. So these people did buy the program. So out of everybody who should be in the stadium, how many people, just this missing person or this missing number X, will buy the program? This is going to help us find how much money we should be making. So cross multiplying. Again, we'll look x times 125, 38 times 54,000. So we get 125x equals 2,052,000. Divide both sides by 125, and we would get x equals 16,416. So this is going to be the amount of people who should actually be buying the programs. Depending on how much the program is, that's a lot of money you could be making. And one more example. In part of a shoreline reserve, there are 45 nesting adult sanderlings and 17 sanderling chicks. There are 120 nesting adult sanderlings in the entire reserve. So how many total number of sanderling chicks would we expect there to be? Well, again, just in this little portion that we are looking at, there are 45 adults and 17 chicks. So it looks something like this, 17 chicks to 45 adults. So if we wanted to find out how many chicks there should be for 120 in total, this would be our completed proportion then, or our missing piece. Cross multiply like we did with the other ones, and we would get 45x equals 2040. Divide both sides by 45, and we'd get, oops, x equals 45.3 repeating. Now, we wouldn't necessarily say that we'd have a third of a chick, so we can round that down to the nearest whole number and just say around 45 chicks we would expect there to be on this reserve. And that'll actually cover it for our first lesson on statistics.